Okay, so welcome back, and now we're going to talk about the law of cosines. Now, in the previous videos we've talked about different types of triangles and how the law of sines helps us to solve those triangles. There are two types of triangles where the law of sines will not be able to help us, and that is where we have all three sides, we know all three sides but no angles. So that's the side, side, side triangle. Okay, so when we have the side, side, side triangle, we can't use the law of sines because we don't know any of the angles, right? So we can't even get it going, okay? So we need to know at least one of the angles, but even if we do know one of the angles, if it's the included angle, right? So if we have SAS, sine angle side, this is another one where we're not going to be able to solve this because, again, we need a ratio of an angle along with its opposite side length. Okay? So in both of these cases, we can't set up the ratio, right? So what do? Well, that's where the law of cosines come in. Now, what is an application of this? Well, let's take this as an example. Let's say we have a ship that left port and went due north, let's say, for 10 miles. And at the 10-mile mark, it turned left or turned northwest, let's say by 20 degrees, and headed another 8 miles in that direction. And the question is how far is the ship from the port? Well, in this case here, we know this length, and we know this length, and of course, using supplementary angles, we can get this angle here, the interior angle, which in this case is 160 degrees. But with that information alone, we would not be able to solve for the distance from the port that the ship is now using the law of sines. Okay, so now what we're going to do is we're going to derive the law of cosines that will be able to help us answer this question and answer any solve for any triangle that fits one of these two. So now, how does that work? Well, I drew this picture on here as a reference, so to show you how we're going to derive this. And in order to derive the law of cosines, it's going to come from the generalized Pythagorean identity, the Pythagorean theorem. Okay. So now, what do you mean by the generalized? Well, remember when we were talking about the unit circle and so on, and we were talking about right triangles. So let's set up this here. So let's say A is at the origin, right? So the A is at 0, 0. So B would be located at what? C, comma 0. Right? So let's say B is located at C, comma 0, because C is the length of this side. Okay? And then C here, now what we're going to do is we're going to drop an altitude. So we're going to drop a perpendicular right here, and we're going to form a right triangle because C is going to be at X, comma Y. That's how we're going to start C, right? So now if we drop the perpendicular, that means we're going to be X away from the origin. So this distance here of this right triangle is X, and the height is going to be Y. Okay, now, we know, dealing with right triangles, and oh, by the way, we know this angle, right? And we know from right triangles that we can rewrite X as what? The cosine, X is equal to what? B cosine theta, right? Because cosine theta is equal to X divided by B, right? So by multiplying both sides by B, we get this. And then Y is equal to what? B sine theta. So we know we can rewrite this as b cosine theta, comma, b sine theta. Okay, so far so good. Now, let's solve for a. Okay, let's solve for this side. How are we going to do that? Well, what I'm going to do is I'm going to use this smaller right triangle because arbitrarily we get this other right triangle. Okay, now I'm going to solve for a using the Pythagorean identity. So what does that mean? It means that x minus c squared plus y squared is equal to a squared. Okay, now what I'm going to do is I'm going to substitute in for x and y. I'm going to use this and I'm going to substitute in for x and y. So now this is going to be b cosine theta minus c quantity squared plus b sine theta quantity squared. And that's going to equal a squared. Okay, now, all I'm going to do is simplify it at this point. Okay, so let's do this. Let's expand this out. So again, I'm going to just FOIL it. So this is going to be b cosine theta squared minus 2, because I'm going to do this times this, and then I'm going to do this times this, so I'm going to end up with 2 of them. So it's going to be 2 times the product of the 2, so it's going to be 2 times bc cosine theta minus, or in this case plus, c squared. Oops. Oh no, that's right. Now, and then of course, I'm going to distribute the square here, and this is just going to be plus b squared sine squared theta equals a squared. Okay, so now what? Well, let's keep simplifying. So this is going to be b squared cosine squared theta, okay, minus 2 bc cosine theta plus c squared plus b squared sine theta. Oh, look at this. I've got a cosine squared theta and a sine squared theta. Let's put those together and they've got this. So let's do b squared. Now they've got a common factor of b squared. So let's factor out the b squared and I get sine squared theta plus cosine squared theta minus 2 bc cosine theta plus c squared equals a squared. Okay, great. Well, this just gives me 1, right? So this is going to end up being b squared plus c squared minus 2 bc cosine theta is equal to a squared. And notice this relationship. So if I want a squared is equal to b squared plus c squared minus 2 times bc cosine theta. And this is one of the laws of cosine for solving for a side of this type of triangle. Okay? Now, there are two other laws of cosines depending on which sides you have, the orientation of the triangle. So I could have, again, this one, so I could have a squared equals b squared plus c squared minus 2 cosine 2 cosine theta. Oops, hold on. Missing my BC. BC cosine theta. So that's one. Now, what if I want to solve for the other angle? Let's say b. Well, then it's going to be b squared equals what? It's going to be a squared plus c squared minus 2ac cosine theta. And what about the final side? What if I want to solve for c? Well, the other one would be what? A squared plus b squared minus 2ab cosine theta. And so these are what we call the law of cosines. And this is what we're going to use to solve things like dealing with side, 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 or side, angle, side. Have a great day.